So how was your quiz? Everything okay with quiz one?
Yes, ma'am.
Okay.
Ma'am, I have doubts on week 6 practice assignment. When can I resolve this?
Week 6 practice assignment, Varun.
I have some doubts left.
Okay, so after revision, after going through summary, you can ask your doubt. I will take that. Is that fine? Yeah,
Okay.
after the summary, you guys can ask doubts from week 6.
Ma'am, can you tell what is difference between sequence and series?
Yeah, I'll explain. So, series is kind of sum of all elements of a sequence, you can think. So, I'll discuss that too. But in our course, we are not talking about series, but I'll give you just what is the meaning of series. So first, so in week 7, so as we go about our content, the week 7 is actually divided into three parts. You can say the first part is some introduction of functions, right? Introduction of functions. How what are the functions are there in this? Sir also take care of trigonometric functions too. So this stuff you guys are already know, and I'll take that at the end of the summary. Okay. So the middle part is the sequences and the limit of sequence. Okay. So limit of sequence. So I'll start from here. So first we will cover what is a sequence is, what do we understand by limit of sequence, and if we have a sequence, then how can we compute the limit of sequence? And after that, we will move to limit of functions. Okay, so this will be our sequence. First, we are going to this topic. We are going to discuss this topic, limit of sequences. Then we will discuss limit of functions, and at the end, we will discuss some basic properties of functions. Okay, so that's the plan. So let's start with sequences. So, but before that, let's understand what is the definition of sequence. In between, if you guys have any doubt, you can either raise your hand or just unmute yourself and ask. Okay. But don't disturb in middle of the topic. After completing the topic, you can discuss. Okay. So let's start with the definition of sequence. So for us, sequence is nothing but a function from set of natural number to any set. Okay. So what is a sequence? So sequence is a function from a set of natural number to any other set. Now this any other set could be set of real numbers, set of rational, set of irrationals, or whatever set you want to take, you can take. So for us, any function from the set of natural number to any other set is called a sequence. Okay. So I'll take one example. So suppose we have a function f from set of natural number to set of real number, such that we know that we can define a function by giving an expression to it, right? So I can say that this function f of x is actually equal to 1 by x. But the thing is, whenever we talk about the set of natural number, in place of taking x, we take n, small n. Okay, so whenever you see a small n, that small n refer to the set of elements of a natural set. That means natural numbers eventually. So whenever we talk about a set of natural number, this is general convention. So in place of x, we just took small n. So this function also can be written as f of n is equals to 1 by n. Okay, so this is an example of sequence. Now here we have domain to be set of natural number, right? And we know that natural numbers can be written down in very nice way. So that means I can write down natural numbers. Since in our course we are treating 0 as a natural number. So I'll start with 0, but this function is not defined at 0. So let me change it a bit. So suppose this is defined like n plus 1. Okay. So we know that natural numbers can be written down in a very nice way. So I can start with 0, then I can write 1, then 2, then 3, then 4, then 5, and so on. What is this? This is a kind of list, right? Listing the elements of set of natural numbers. In same way, we can also denote a sequence. So for example, this sequence we have, this sequence can also written as that if you take f of 0, so that means this also written as f of 0, comma f of 1, comma f of 2, comma f of 3, comma and so on. Yeah, and f of n and then and so on. So that means what we are doing, we are just listing out the elements of sequence. But what is f of 0 here? F of 0 is 1, f of 1 is 1 upon 1 plus 1, which is 1 by 2, 1 by 3, 1 by 4, and so on. So this is another way of denoting a sequence. So the first way is denoting by its expression, that f of n is equals to 1 by n. Second way is denoting by a list of elements of that sequence. That is, the sequence is 1, comma 1 by 2, comma 1 by 3, and so on. So here you can observe that each term happens to at a specific position. So for example, the position of this first term is, it's a first term of the sequence, right? This is the first term. What is the position of this guy? This is the second term, right? And so on. If I write down the nth term, then that will be 1 upon n plus 1. So that means every term has its own position. So that position is known to be the number of terms. So that means this fn can be also written as an, where this a script n is actually denote the nth term of the sequence. So the sequences also can be written as a script n or b script n type of thing, where an and bn is actually denoting the nth term of the sequence. So this specific sequence f of n can be written down an is equals to 1 by n plus 1. Where here what is a script n? A sub n, it's actually the nth term of the sequence. Okay, so these are the general notation for denoting a sequence. So I'll repeat again. So what is a sequence? Sequence is a function from set of natural number to any other set. Any function from set of natural number to any other set is known to be a sequence. How can we denote a sequence? Since it's a function, we can have an expression for a sequence. But since we are talking about natural number, in place of x, we just write down small n. So we can say that f of n is equals to 1 by n is a type of sequence. Also, a sequence can be written down in terms of its elements. So that is f of 0, comma f of 1, f of 2, f of 3, and so on. So you can list out every term of a sequence. So in this way also you can represent a sequence. So it is a sequence whose first term is 1, second term is 1 by 2, third term is 1 by 3, and so on. But in sequence, the nth term or whatever position we have that term is actually denoted by a sub n. So this a sub n is actually denote the nth term of the sequence. So that means this fn can be replaced by a sub n. So you can say that a sequence is defined like a sub n, where a sub n is 1 upon n plus 1. So that is the term of sequence is defined by this particular expression. So in sequences, we generally took this notation a sub n in place of f of n. Okay, so that's all. So these are the notation of sequence. So is there any doubt in sequence? Yes, Varun.
Ma'am, I have a doubt.
Yeah.
Ma'am, can we define that nth term of a sequence is defined on a real number?
Nth term of the sequence define or a real number means, here can we take domain as a real number? Is that your question?
Yes.
No. The sequences are defined to be a functions from natural number only. Because the thing is, with sequences, you can actually talk about the counting, or you can actually talk about the ranking of each term, right? If you take real number, then in real number, there is no first and second, right? In real number, you have infinitely many numbers between 1 and 2. So that's why when we talk about sequence, we are restricting ourselves to consider the domain to be natural number. So if a function does not have a domain natural number, it's not a sequence. Is that clear?
Yes, ma'am.
So this is definition. So you don't have to, you have to stick with definition whenever we talk about sequence, from set of natural number to any other set. Okay, fine. Now there is one more way by which you can actually define sequences, and that way is known to be the recursion relation. Okay. So what is recursion relation means? You can actually relate the next term of the sequence with the previous term with some expression. And by that argument, you can define what is your sequences. For example, not this sequence. If I have a sequence like this, suppose an is a sequence where an is given by 2 to the power n, right? So that means this sequence is simply 2 to the power 0. 2 to the power 1, 2 to the power 2, 2 to the power 3, and so on. This is the sequence. Now, this sequence also can be denoted by or can be demonstrated by another relation. And what is that relation? You can simply say that here we can take this particular sequence can be denoted by we can first assume what is the value of first term, that is what is the value of a0. So I am taking a0 is 1, and I am saying that the value of a n plus 1, that is the value of n plus 1 term, is actually equal to 2 into the value of a, right? So here what I am doing, I am relating the next term of the sequence with the previous term of the sequence, and here I have some initial condition type of thing, that a naught is equals to 1. So in place of this expression, so now for timing, if you forgot about our sequence, if someone says that your sequence is defined like this, where a naught is equals to 1 and an plus 1 is equals to 2 into an, then can we figure out the sequence? So by this argument only, so that means only
Ma'am, can you
observing this
repeat it over one more time?
yeah, so see, initially, what is recursion relation means, we can actually have a relation between the next term of the sequence with the previous term of the sequence. Okay, so I'm taking an example. So for example, you have this sequence, an is equals to 2 to the power n, right? So this sequence is actually this particular sequence, right? 2 comma 2 to the power 1 comma 2 to the power 2 and so on. But this particular sequence also can be written down in a different manner. So what is that different manner? In the different manner, I'm saying that first term of the sequence is 1, and the n plus 1 term, that is the n plus 1 term of the sequence, is actually 2 into an term. So let's try to figure out what does this particular statement says. So if you have this statement, what does it means? It says that a naught is equals to 1. Okay. So what is the value of a1? So for a1, you have to take this particular expression. So it says that a1 is actually 2 into a naught, right? So it says that a1 is actually 2. Okay. So what is a2? A2 is saying a2 is actually 2 into a1. So what is 2 into a1? 2 into a1 is 2 into 2, which is 2 square. What is a3? A3 will be 2 into a2, right? An plus 1 is equals to 2 into an. So if I am taking n is equals to 2, that says that a3 is equals to 2 into a2, right? That is 2 into 2 square, which is 2 cube. So that means if I define a sequence in this way also, you are getting the same sequence, which is an is equals to 2 to the power n, right? So this is another way of denoting a sequence, and this way is known to be the sequence by recursion relation. Right? Recursion means that we are relating the next.
Ma'am, you are not audible, ma'am.
Hello, I'm audible.
Yes.
Yes, ma'am.
Yes, ma'am.
Yeah. So the thing is, power cut just had happened, so we have to wait for 5 minutes. So what can I do? So I'll try to teach with my mobile network, but it may happen that you guys may not hear some things or the screen will start lagging. Okay. So just bear with that. I hope light will come in 5 to 10 minutes. Okay, power will come.
Meanwhile,
Is
I
that
have one
fine?
small doubt.
You guys are able to hear me? Yeah.
Yes, ma'am. Meanwhile, I have one small doubt. Ma'am, what is the
Yeah. So
difference
what's the
in
doubt?
progression
Uh-huh.
and sequence?
Progress. Sequence is well-defined quantity accepted in our mathematics, but progress, there is no definition for progress. So you can say that sequence and progress are same thing, but you have to define what is a progress means.
Progression,
What
ma'am.
is progress
Like
actually? Can you?
progression,
Oh, okay,
arithmetic
okay, yeah,
progression.
yeah, yeah. Got it, got it, got it, got it. Got it. So these arithmetic progression, geometric progression, these are examples of sequences. You can take it examples of sequences. For example, this 2 to the power n is also a geometric progression, right?
Yes, ma'am.
So these are example of sequences.
Like it is a part
Arithmetic
of
progression,
sequence,
geometric
right?
progression.
It
हाँ.
comes. Okay.
So these are general type of sequences with very nice form, right?
Ma'am, for 7th week we are having sequence and series only, ma'am. Then why in the video lecture, first two or three videos, they're just teaching previous content.
Yeah, this is because in our content in week 7 content, the first 3 to 4 lectures are concentrated on types of function. So that's why they are teaching that. But we can skip that because we already know what are the types of function. We already been through the properties of function. So that's why I'm starting with sequences. So it's just kind of recap you can think.
Yes, ma'am. Ma'am, another doubt in upcoming test for August 3 only, ma'am.
Hmm. Sorry, what?
Ma'am, the upcoming
For
quiz
August?
2 will be conducted on August 3 only, ma'am.
Yeah. August 2.
Ma'am, for that, any how for first 4 weeks will be marks count will be less. For the next 4 weeks, will marks count will be high. Like that, any weightage, ma'am?
Yeah, right. First 4 week will contain very less weightage, and last 4 week, and you can say precisely last 5 weeks. Sorry, yeah, last 4 weeks will be of much more content. Yeah, will be of much more. You can say credit or marks.
Weightage.
Okay, so
Is
I'll
quiz
try to share my screen. So let's see if it work or not.
is
Yeah.
quiz 2 compulsory for all?
If you want to go ahead with the course in this term, then yes, it is compulsory actually.
Compulsory for foundation.
Compulsory for foundation.
Ma'am, so like the end term will have like all the chapters, right? From 1 to 8, the whole eight
Right.
weeks.
Hmm. But also there will be some distribution of marks. So that means the last 4 week will take care of most of the paper, and there will be 30 to 40% are from week 1 to 8. So we'll give you the mark distribution in the revision session. In this term, I think we haven't gone through the mark distribution, but for quiz 2, you can have because the
Okay, ma'am.
syllabus will be bigger, right? Okay,
Yes,
so
ma'am.
I'm trying to teach, so let's see if it works or not. But let's see. Okay, so this is the meaning of defining a sequence using recursion relation. Recursion means we have relation between the first term, between the next term and the previous term of the sequence. Okay, I hope that's clear.
Yes, ma'am.
Now I'll take one more example. How can you define the sequence using recursion? So suppose I'll give you a relation like a naught is equals to 7 and an plus 1 is given by under the root of 7 plus an. Right? So suppose this is a sequence. Now how this sequence turn out to be? So we are given a naught to be 7. What is the value of a1? A1 says that under the root of 7 plus a naught. So let's take it under the root of 7. Okay, so this a1 says that a1 is equals to under the root of 7 plus e naught. What is this? This is under the root of 7 plus under the root of 7. Right? Then what is a2? A2 will be under the root of 7 plus a1. So that is under the root of 7 plus under the root of 7 plus under the root of 7. Right? So that means this sequence you can easily. So this is something. If you want to write the nth term of this sequence, it will be a little bit complicated, right? So if I want to write down the nth term, en, then it will look like some under the root of 7 plus under the root of 7 plus under the root of 7 and plus and so on. I have to justify how many under the roots and how many sevens I am taking here. Okay, so that means here we have to just giving the expression of nth term is kind of little bit messy, or it's not that clear, you can say, right? So what we can do in place of this, we can stick to our recursion relation. So in such kind of example, recursion relation turn out to be very nice to handle. Okay, is that clear?
Yes,
Yeah, but this recursion relation is not there in the topic, like in the videos.
uh yeah, they haven't mentioned in detail actually. They But in activity and practice, I think you may find some of the question related to this.
Okay, I went through all, but I didn't find. Okay, fine. Anyway.
Hmm. Uh, let's see. Okay, so now let's talk about the main topic, which is the limit of sequence. Okay, limit of sequence. So, what is limit of sequence is we just want to answer a question that if n goes to infinity, where does the term Cn goes? Right? So this is the basic question we want to understand, that if you take n to be infinity, so that means if you take larger and larger values of n, where does these terms an actually goes? Or what is the number around which these terms will get clustered into? Okay, so this is the question we want to understand. The original definition of limit is actually a little bit you can say abstract. So I'll just mention the definition. Don't bother to if you don't understand, that's also fine. So definition of limit actually says, this epsilon delta definition is says, we say that limit n goes to infinity, this an, that is the limit of sequences, is a number small n, small l, if for all epsilon strictly greater than 0, there exists an n belongs to natural numbers such that the terms of sequences are lying between the epsilon neighborhood of L. So that is the sequence an, that the terms of sequence belong to L minus epsilon comma L plus epsilon for all n greater than or equal to capital N. Okay, so just be with me for the next 5 minutes. Let's try to understand what is this definition means. So it says that this is the abstract definition of limit of sequence, original definition. But we will never use this definition to find the limit of sequence, because applying this definition is actually very uh, uh, it's little bit of tough thing, because see, in the definition itself they are using the limit. So that means first of all you should have a good guess about the limit, that what will be the limit of sequence might be, right? So what does this definition says? This definition says that no matter what number you will choose, no matter what neighborhood you will choose around the value L, so if this is the value L, then no matter how big or how small neighborhood you will choose, then there should exist some n belongs to natural number. That means there should exist some step n, so that if you take any natural number after this particular step, or if you take any term of the sequence after this particular steps, the term of sequence should lie inside the epsilon neighborhood of L. Right? So that is the meaning of limit of sequence. So ultimately it says that as n goes to infinity, these values of this term of sequence are somewhere getting more closer and closer to the number L. So if you want to say this mathematically, you have to go with this definition. But I'll again repeat, we won't use this definition at all for computing the limit of sequence. It's just there because it's the original definition of limit. That's how the limit of sequence actually defined. Yes,
Excuse me,
Vaibhav.
ma'am.
Yeah.
Ma'am, is there any relation between capital N and small l?
Yeah, both are actually, you can denote capital L by limit of sequence, small l by limit of sequence. It's up to you.
Ma'am, capital N,
Both are same actually. Capital N.
like you have denoted
Yeah,
on.
no. There is no relation. Sorry. I heard L. So there is no relation. This capital N actually depend on the choice of epsilon. So if you take bigger epsilon, then it might happen that capital N is a smaller natural number. But if you take smaller neighborhood, then you have to think about capital N. What will be that capital N?
Okay, ma'am. Thank you, ma'am.
Yeah.
So,
Can
ma'am,
you
for
can you
the
explain this one
domain
more
of
time? Whatever
One
is
by
this
one.
like? Can you explain it one more time?
Can you explain what?
Can you explain this one more time? This L epsilon.
Right. Yeah. So the thing is, what is happening here? We are saying that the limit of sequences. So I'll explain by graph this time. Okay. So suppose this is your graph, and you are plotting the term of sequence in this particular graph. Okay. So suppose this is 0, this is 1, this is 2, this is 3, and so on. And here you are plotting the numbers a0, a0, the value of a0, a1, a2, a3, and so on. So what is limit means? Limit means that value of L. So this is the value of L. So this L is called the limit of sequence if you just make a smaller rectangle strip here. So this rectangle strip means you are considering the neighborhood L minus epsilon and L plus epsilon. So this is your L minus epsilon, L plus epsilon and L minus epsilon. So for every smaller and very small rectangular strip, you are able to find out a step n, after which that all terms of sequence are kind of lying inside this particular rectangle strip. And this should happen for all smaller and smaller rectangle strip. Here I'm taking one example, but this should happen for all epsilon greater than 0. So if such thing happens, then it's known to be a limit of sequence. Okay, but if you don't, if it's not that easier to understand, then forget about it. Okay, it's just for your knowledge that how actually the original definition of sequence is. But ultimately, you just have to make a guess of this thing. That as n goes to infinity, where does an goes? Okay, and we will figure out this thing for very small or simple type of sequences, and then we have some rules by which combiningly you can talk about the limit of sequence in general. Okay, so for you guys, just try to understand for very simple sequences. For example, if I give you, if I ask you this question, if n goes to infinity, where does 1 by n goes? So what will be your answer?
0. 0.
0, right? So
0.
it's kind of obvious. So we just want to figure out these type of simple things in our course. So this is abstract definition of sequence, but you should know how this limit of sequence actually defined. But if it is too tough, just leave it. We will never use this definition in our course. You just have to, or in future also, there might happen that you will never use that limit of sequence definition. Ultimately, we just go with our intuition that if n goes to infinity, where does 1 by n goes? 1 by n goes to 0, right? So the answer is this 1 by n actually goes to 0. Okay, so let's ask one more question. So if I ask you, now I'll write it down. So what is the limit of sequence n square?
Infinity.
Infinity.
Infinity, right? Because as n goes to infinity, n square will also go to infinity. So it's kind of obvious. So if n goes to infinity, n square also goes to infinity. Now let me ask you one more question. So what do you guys think? What is the limit of sequence minus 1 by n to the power? Sorry, yeah. Uh, this is this. So what is the limit of sequence minus 1 to the power n by n? Here, if n goes to infinity, what do you guys think this term will go to which value?
0.
0.
0, right?
Yes.
Yes. 0.
0. Why it is 0? Because you can see that as if you take n is equals to 1, the value is minus 1. This is our 0. N is equals to 2, you will getting 1 by 2. If you take n is equals to 3, you are getting minus 1 by 3. If you take n is equals to 4, you are getting 1 by 4. So ultimately, the term of sequence is being very close and close to the value 0. So that's why the limit of this sequence is 0. So here we just have to intuitively think of small sequences if n goes to infinity, where does these three sequences actually converge. So if you know these limits, then you can find out limit of so many other sequences just by decomposing that sequence into this particular form. So I'll take example over that too. So before that, I was going to say, yeah, let me define two terminologies about sequence. What is the convergence and divergence meaning of a sequence? Okay. So here, can you guys tell me, uh, can we talk about the limit of this sequence? An is equals to minus 1 to the power n. Is there any fixed number where the sequence goes as n goes to infinity, or it is fluctuating between two values?
Ma'am, it's fluctuating between minus 1 and 1.
Fluctuates.
Correct. So that means here we cannot answer the question that as n goes to infinity, we cannot say confidently that where this particular terms an goes. Then an is equals to 1 for, so you can simply say that we cannot say, we can't say anything about an, right? So as n goes to infinity, here the value of sequence is actually fluctuating between oscillating between two values, correct? Oscillating between minus 1 and plus 1. Because here what is the sequence? The sequence a naught is 1, minus 1 to the power 0 is 1 actually. So a naught is 1, a1 is minus 1, a2 is 1, right? a3 is minus 1. So in this type of sequence, we actually cannot figure out any fixed value. Where does it go? Yes, Varun.
So this is applicable for all the n values. I mean, an.
All the n values means you're talking about what?
If you are defining some an equal to some, you are defining some other values. then we cannot able to determine about the exact value of A, right?
Right. So that means as n goes to infinity, we cannot say where does it actually goes.
Also, this is a kind of an exception.
No, it's like these type of sequence does not converge to a single limit. So here we cannot talk about limit. That means in these type of sequence you can say that limit does not exist. Is that okay?
Okay.
Okay. So why I have taken these three examples is I want to explain what is the meaning of convergent of a sequence and divergent of a sequence. Okay. Convergent. So convergent means we say a sequence. So actually sequences are denoted by these curly bracket inside an. So this is the symbol for saying that an is a sequence. Okay. So we say that a sequence, this is a sequence, converges. Okay, converges, or it is a convergent sequence if the limit of the sequence is not equal to plus or minus infinity. Okay, so if limit n exists and not equal to plus or minus infinity. So what is the meaning of convergent sequence? Means a sequence whose limit exists and that limit is not equal to plus or minus infinity. That sequence is known to be a convergent sequence. Okay, so that means the
Samiksha, we
sequence. So
lost
you
you
can take
for the
example as 1 by n.
Samiksha, we lost you for the last 10 seconds. Can you repeat what you said about
Okay.
convergent?
Yeah. So I was saying that we say a sequence is convergent if the limit exists and that limit is not equal to plus or minus infinity. So those type of sequence are known to be convergent sequence, and we say it converges to limit of n. So whatever limit we say that. So for example, the sequence 1 by n. So this is a convergent sequence. Convergent sequence. And we say the sequence 1 by n converges to 0, which is the limit of sequence. That is the meaning of convergent sequence. Am I audible clearly now?
Yes.
Yes, you are audible now.
Yes, ma'am.
Yeah.
It means like the limit should not be plus or minus infinite. That's all right.
Right. The limit should not be plus or minus infinity.
Any other value than plus or minus infinity.
Yeah, any finite value.
Oh.
First of all, limit should exist and should be finite. Yes, Kavya.
Okay.
I think
Ma'am,
Kavya is.
yes, ma'am. Ma'am, will we always checking for the limit extend to infinity or any other number?
No. Here, whenever we talk about a sequence, so sequence is defined over natural numbers. So that's why we can only talk about n goes to infinity, right? We cannot talk about any finite value in this case. When we move to limit of functions, there you can take any finite value in place of infinity. Here you just have to think about as n goes to infinity, where does en goes? Because we know sequence are defined on natural numbers. Is that okay? Yes, Dilip.
In some
Okay, ma'am.
cases, they talk about like something converging to infinity, right? So they use the term converging to infinity. So that doesn't mean it's convergent.
Yeah, it doesn't mean convergent. So they will they have to explicitly say converging to infinity or what. If they are saying convergent, then you have to assume that limit is a finite value.
Okay.
Okay. Is that clear? Shall we move to next? Yes.
Did you just discuss that if we say that the limit is infinity, that means it's not a convergent?
Right.
Okay.
For sequence, there is no direction, right? Like left to right and all. It's like directly one
Right.
direction.
In sequence, there is no direction because we have natural numbers, so we can just go to infinity. We
Got
can't
it.
go anywhere.
Yeah,
But in
thanks.
functions, we will see when we'll
See
talk
with
about
right.
left
Okay,
hand limit
got
and
it.
right hand limits.
Got it.
Okay. So now let's understand some of the basic rules, which I think you guys are familiar. But see, not examples, rules. So these rules says if you have two sequences which are converging to somewhere. So suppose, so let us assume that the limit of sequence an is a, and limit of sequence Bn is B, then you can easily say that the limit of sum of the sequences an plus bn. So sum of the sequences means we are adding sequences term by term. So that means first term is added to the first term, second term is added to the second term. For example, if you take this sequence an to be equal to 1 2 3 4 5 and so on, and if you take another sequence bn to be equal to 2 4 6 8 and so on, then the summation of these two sequences means you have to add term by term. So that is, this one will be added to 2. That means first term is added to first term, and that then we are getting the first term of an plus bn. So this is 3, then 4 plus 2 will be 6, then 6 plus 3 will be 9, then 8 plus 4 will be 12 and so on. So that's how you will do addition of two sequences. Similarly, multiplication of two sequences also can be done term by term. That is, first term got multiplied by first term, second term got multiplied by second term and so on. Similarly, division and all other operations. Also the scalar multiplication too. So for example, if the sequence an is this 1 2 3 4 5, then what is the sequence 2 times an? So 2 times of an sequences 2 multiple of each term. So that is 2 into 4, right? That is 2 4 6 8 10 and so on. So that's meaning of these operation. Addition of two sequence means add term by term. Multiplication of two sequence means multiply term by term. And scalar multiple of any sequence means multiply that scalar by each and every term. Okay, is that clear? Fine.
Yes, ma'am.
Yes.
Okay, so this rule says if an is going to a and bn is going to b, then an plus bn will go to a plus b. Okay, so here observe the direction. Direction means first I'm assuming that an is going to a and bn is going to b, and then I'm claiming an plus bn will go to a plus b. Okay, but here in this particular result, the converse is actually not true. Converse is actually not true means if you have that the addition of two sequences convergent or addition of two sequences possess some limit, this does not imply that individual sequence will also possess the limit. So can you guys tell a example for this converse, why this is not true? Think of two sequences whose addition is converging, that is, addition possesses some limit, but individual sequence does not have any limit.
Maybe 1 minus 1, 1 minus 1.
Correct. So that's a very simple and basic example for understanding this one now.
Yeah,
So
minus 1 to
I
whole power
want to
n and
say
minus 1 the whole power n plus n.
right. These are the two sequences en and bn you can take. So if you add them, you will get a constant sequence 0. So here addition has a limit, but individual sequence does not have a limit. And this is true for every other rule. So here I'm just explaining for addition. Similar thing is true for subtraction too. Similar thing is true for multiplication and division too. So it's up to you. You guys can easily find out what are the examples you can take. Okay. So I'll recall what is the point here is. So first, if we have this condition that an is going to a and bn is going to b, then you can apply an plus bn will go to a plus b. But you cannot go other way around. So that means if you have a sequence if you have two sequences whose addition has some limit, then you cannot say directly that individually these two sequences will possess the limit. Okay. So I'll make a remark here. Write down. So remarks, if n plus bn go to L, some finite value, then the individual sequence, then n and n need not have limit. Okay, so we can take example an to be equal to minus 1 to the power n and bn to be equal to minus 1 to the power n plus 1.
How to find if
Okay. So
sequence?
here if you sum it n plus bn, sorry, what? How to find?
How to find a sequence has a limit or not?
Just think, if n goes to infinity, if that particular sequence goes to a fixed number, then it has a limit. If it's not going to a fixed number, so for in this case, as n goes to infinity, sequence can go to either plus 1 or minus 1, right? It's not going to a fixed number. then sequence does not have a limit. But here it's just a constant 0. As n goes to infinity, this will also goes to 0. So that means the sequence has a limit and it's equal to 0. Okay. Is that clear? Fine.
Okay. Clear, ma'am.
So same type of rules we have for subtraction, multiplication, and division too. So I'll just write it down. So the second rule says, again, I'm taking if an and bn goes to a and b, then the limit of sequence an minus bn is actually equal to a minus b. The limit of the sequence c multiplied by an is actually ca, where c is any real number. Right? The limit of the sequence an by bn, and here we are assuming that bn is not equal to 0 for any n, is actually equal to a by b, and b is also not equal to 0. Okay, so these are the 4 basic rules about sequences. So that means if an goes to a and bn goes to b, then a plus is bn goes to a plus b, a minus bn goes to a minus b. Any constant multiple of an will goes to c into a, so that is the constant multiple, and an by b go to a by b. Okay, so let's take a small example over these rules, how we can use them. Okay, so I'll ask you guys to compute the limit of this sequence. So what is the limit of the sequence n to the power 7 plus 10 n to the power 7 plus 6n to the power 6 plus 5n to the power 5 plus 4n cube plus 3n square plus n plus 1 upon 8n to the power 7 plus 9n to the power 6 plus 3n cube plus n plus 1. Okay. So what do you guys think? What will be the limit of this sequence? So this is your an.
5/4.
5 by
Just
4.
5 by 4, right? So just an example of how we can use these limits. So what we are doing here,
Ma'am, can
we
you
know a simple limit.
ma'am, can you guide on how to
Yeah.
do this?
I'll. So see, here what is happening, we know this limit, that limit n goes to infinity, 1 by n is actually equal to 0. Okay, so what we will do, we'll try to decompose the sequence in form of this small factors, and then we will use the knowledge of this limit and we can compute the limit. Okay, so what I mean by that is, whenever you have such type of rational sequences, rational sequence means polynomial upon polynomial, right? Numerator is polynomial in n, denominator is polynomial n. Then what is the step? So first of all, you have to take common the largest power of n from the numerator and denominator, right? So this is your first step. So you have to take common the largest power of n from the numerator as well as from the denominator. So that means this is same as limit of, this thing is same as saying limit of the sequence. Here, what is the largest power of n? Is n to the power 7. So n to the power 7, and the denominator also, the largest power is n to the power 7. Right? This is n to the power 7. Now, here in the from the first term, if you take out n to the power 7, then what is the remaining factor is 10. Right? So the first term leaves 10 only. Then in the second term, what will happen? So in the second term, we don't have n to the power 7 exactly. We have 6 n to the power 6. Okay. So in the second term, what we have? We have 6 n to the power 6. But this thing, you can write it down 6 into n to the power 6 into n by n. Right? I'm just multiplying and dividing by n. So this is same as saying 6 n to the power 7 by n. And from this term, I can take common n to the power 7. So this is same as n to the power 7 bracket of 6 by n. So that means if I take out n to the power 7 from 6 n to the power 6, the remaining factor will be 6 by n. This is 6 by n. So here you will get 6 by n plus. Okay, same thing we'll do for other remaining factors. So just give me a second to connect with the Wi-Fi first. Okay. So am I audible now?
Yes.
Yes.
So now what will be the next term? Next term is 5n to the power 5. Now what we want to take
5 by
out,
n square.
right, so 5 by n square will be there. So the method is easy, right? So I'll just explain one more time. 5n to the power 5 is there. This can be written it down 5n to the power 5 into n square by n square. You can multiply and divide by n square. And why I'm taking n square? Because if you multiply n to the power 5 with n square, you will get n to the power 7. That's why I'm taking n square. So this will be 5n square, 5n to the power 7 upon n square. So if you take out n to the power 7, you will get 5 by n square. So same thing you have to do for each and every term. Okay. So here you will get 5 n to the power 5 by n square. In the next term, we have a, this is n actually, n cube. So if you want to make n cube into n to the power 7, you have to multiply and divide by n to the power 4. So here you will get 4n to the power 4. Similarly, plus 3n to the power, here we have 2. So that means n to the power 5, we have to multiply and divide. Plus n is there, that is 1 by n to the power 6 and plus 1 by n to the power 7. Okay, is that clear? Fine. Same thing you will do in denominator too. So in the denominator, if you take common n to the power 7, you will get 8 plus 9 by n plus 3 by n to the power 4 plus 1 by n to the power 6 plus 1 by n. Okay. And now we can apply this limit as n goes to infinity. We know 1 by n goes to 0.
1
So
by
now,
1 by n to the power
n to the
7.
power 6.
oh yeah,
7.
7. I missed that. Okay. So here if you apply the same thing, as n goes to infinity, this term will go to 0, this term will go to 0, this term will go to 0, right? All these terms which have n in denominator, all will go to 0, right? In the numerator too, these all will go to 0. So at the end what we have, and this n to the power 7, n to the power 7 will get cancelled out with each other. So at the end, if you apply n goes to infinity, we are left with 10 by 8. Because 10 will remain 10 only because it's a constant sequence, right? And 8 will remain 8 only because there is no involvement of n. So if you apply the limit, these two numbers won't change. So that's why we have 10 by 8 and this is same as 5 by 4. That's how you can compute the limit of any type of rational sequences. You can just see and you can simply tell what will be the limit. Okay. So let me ask you, okay, you guys can find out some
Ma'am,
question in this.
or one doubt, ma'am.
Yeah. What's your doubt?
Ma'am, I have one doubt.
Hmm.
Ma'am, in the given question, if in denominator 8 n power 7 is not there,
Then
then
this,
how you will compute?
yeah, then limit will be infinity, right? Because in the numerator you have larger power. So as n goes to infinity, numerator will take care that all thing will go to infinity. So here you will, after doing all these things, here you will get some n, some remaining n. And this n goes to infinity and this is a finite value. So everything will go to infinity. So if the degree of numerator is bigger, then limit of the sequence will be infinity. Okay. And if the degree is smaller, then that limit will be 0. So let's just take two simple examples. So the limit of the sequence n cube plus n square plus n plus 1 upon n square plus n plus 1. Or you can take n square plus n. What will be the limit of the sequence?
Infinity.
Infinity, right? This will go to infinity because here we have n cube. So this can be written it down, limit of, you will take n cube common, you will get 1 plus 1 by n plus 1 by n square plus 1 by n cube. From the denominator, the largest power is n square. If you take n square common, you will get 1 plus 1 by n. After simplifying it, you will get limit of, here you will get n, and here you have this finite thing, right? 1 by n square plus 1 by n cube. And in the denominator, you have 1 plus 1 by n. Right. So as n goes to infinity, these all term goes to 0. This one remain as it is. This goes to 0. This one remain as it is. So that means as n goes to infinity, this whole factor is going to 1, which is a finite value. Right. And as n goes to infinity, this n will also go to infinity. So that means what we are getting? We are getting infinity into 1, which is nothing but infinity. So that's why as n goes to infinity, this whole sequence will go to infinity only. Okay.
Ma'am,
So that
then
means
if a degree of like a denominator is higher than numerator, then the answer will be 0, right? The
0,
limit will be.
right? Correct. So if you compute this limit,
Okay, ma'am. Thank you.
so similarly,
Ma'am,
The limit.
infinity by infinity is equal to 1 now, ma'am.
No, actually, it's not. Because here only you can see. In this example, the upper sequence, if you individually consider this sequence, this is going to infinity, right? With just a
Yes,
polynomial.
ma'am.
Denominator also going to infinity. But infinity by infinity is not 1. This is a finite thing.
Is there any value for infinity by infinity? How we are saying 0 by 0 is infinity like that?
How we are assigning 0 by 0 what?
As infinity?
Means? I'm
Huh?
not getting your point.
I'm like that. I'm just telling that we are just considering 0 by 0 as infinity now. It means infinity by infinity as 1.
No, we are not considering that. Infinity by infinity is not 1.
Oh,
See, that's
then
why I said
write
here.
the undefined forms, like it will give a little clarity.
It's a indeterminate form. So for those things, you have to apply L'Hospital. You guys know L'Hospital rule, right? Or
ma'am.
we can also discuss that.
L'Hospital is in week 8.
Okay, it's in week 8. So there you can discuss. So infinity by infinity, 0 by 0, these are all known indeterminate forms. So you cannot assign a finite value to these things. So we'll talk about that too. Okay. So infinity by infinity is not 1. Infinity is not a number, it's just something to denote that something is very big. Okay, so we'll understand that. Okay, so for these type of sequence, the computing limit is very easy. Now we have one more rule. It's known to be a sandwich theorem or squeeze theorem, whatever you want to say, you can say. So this theorem goes like this. So if you have a sequence which is being sandwiched between two sequences, and if both sequences are converging to the same limit, then they will restrict the middle sequence to go to the same limit. What I mean by that, so suppose we have three sequences A and B and C n, such a way that the value of an is less than equal to bn is less than equal to cn, and these two sequences an and cn are actually converging to the same limit. So that is, and limit of an is same as limit of cn, and suppose we will say l. Okay, so if this thing happens, then these two sequences force the sequence bn to converge to the same limit l. Then bn also converges to l. This is known to be a sandwich rule or sandwich theorem. So it simply says that if you have three sequences with this manner, that if an is less than equal to bn is less than equal to cn, and if the outer two sequences are converging to the same limit l, then these two sequences combiningly force to this sequence goes to a same limit 0. Not 0, l, sorry. That means bn also converges to the same limit l. Yeah, any doubt?
Ma'am, so here the condition is that first an has to be convergent and is going on
Yeah.
one limit, and cn has to be convergent going on same limit, then only the
Yeah.
case applies.
Correct. Yeah, then only you can apply.
So B
Ma'am,
of n is an intermediate between A and Cn, right?
Means?
I meant say that limit of B of n should be equal to limit of A of n and limit of C of n.
Right. So that's the implication, that's the result, that limit of bn will be same as limit of an and limit of c.
Ma'am, can you explain on that example sin x by x is equal
That
to 1?
right. That's the same example I'm going to do. So
Okay,
what
okay.
does this example says? So we
I have
want
a
to
doubt
compute.
in the definition. Can you scroll up?
Yeah.
What do you mean by an less than or equal to? No. The theorem definition. An less than or equal to bn less than or equal to cn. What does it actually mean?
It means that every term of sequence should satisfy this inequality.
So
That
across
that
n,
means first term
for
a1 is
all
less than
n,
equal to b1.
an should be
For all,
less than b. Oh, okay. Got it.
right? This thing should happen for all n belongs to answer. Okay, that every term of the sequence satisfy this particular inequality.
Ma'am, here n will tend to infinity or some other constant?
No, infinity only. Whenever you talk about sequence, n only goes to infinity.
Oh, thank you, ma'am.
Okay. Then this limit of bn is equals to l. So the thing is, the limit n goes to infinity. The sine n upon n is actually equal to 1. So why it is equal to 1? So you know that the value of sin n lies between plus and minus 1. So we know that the sin n is actually less than or equal to minus greater than or equal to minus 1, less than or equal to plus 1. So you can say that the value of sin n by n is greater than or equal to minus 1 by n, and it's less than or equal to 1 by n. Right? So here the sequence is your bn. Right? So here you can say that an is actually equal to minus 1 by n, bn is actually equal to sin n by n, and cn is equal to 1 by n. Right? And we know that an, which is equal to minus 1 by n, this goes to 0. Cn, which is equal to 1 by n, this also goes to 0. So that means Cn and An both are convergent and they are going to the same limit. And here we are satisfying this inequality that An is less than equal to Bn is less than equal to Cn. That's why Bn will also goes to. Did I did any mistake? The limit should be 1, right? Why it's getting 0?
And because you are tending n to infinity.
Right. Yeah, correct. There is a limit na that sin x by x is equals to 1, but sin n by n is infinity.
That is 1 when n tends to 0.
Right, correct. So in this case, bn also goes to 0.
So
Yeah.
for that, can we use the
Yeah.
inequality of x less than sin x less than x minus x cube upon 3 factorial, like, and then divide by x and then apply the
Yeah, so
limits?
but their limit is x going to 0, not x going to infinity, right?
Yes, for that
Huh.
only.
For that only. Yeah, that's why I got confused. So here we are talking about n goes to infinity. For n goes to infinity, this inequality is true. Because the only thing which happened wrong is in between 0, near 0. But here we are very far away from 0. So that's why this limit is 0. Sorry for 1. Okay, so that's how you can apply. So again, here also you have.
In minus 1 by n, when you apply in 0, it will become infinity, right?
No, we are talking n goes to infinity only, not 0. As n goes to infinity, minus 1 by n will also converge to 0, right? Minus 1, minus 1 by 2,
Correct.
minus 1 by 3.
Yeah.
Okay, so now let's
No, I
go
didn't
to.
understand that part. Can you repeat that, please? So you're
See,
saying n is tending to infinity, so an is actually going to infinity, meaning going to 0. Cn is going to 0. That much I understand. So sin n by n will be 0, is it? If n tends to infinity.
Yeah, right. As n goes to infinity, sin n by n is 0.
Okay, got it.
Okay, so this means sin n by n goes to 0. Okay, so that's much about sequences. There are
Ma'am,
one
can you
more
explain
topic.
cos and tan as well?
Yeah. So what is? I'll explain
What is?
all. Yes, Suraj. Any doubt? Okay. So see, sin x is actually a trigonometric function. So the thing is, if you have any right angle triangle, no matter how big or how small that right angle triangle is, if you take until and unless the theta is same, until and unless the angle is same, so then the ratio of these sides OMN, O dash, M dash, N dash. So the thing is, these ratio that OM upon ON, this will be same as O dash M dash upon O dash N dash, right? So so whenever you have a same angle O for the right angle triangle, the theta is same. So no matter how big or how small your right angle triangle is, these ratio will always same, and these ratios are uh, given to be a specific name, and those name is sin theta, cos theta, and tan theta. So that's how we define the functions, trigonometric functions, sin x, cos x, and tan x. So if you have right angle triangle, then you guys know what is the value of sin theta, so cos theta, and tan theta. Okay. So sin theta is actually the mn upon on, right? Cos theta is defined to be om upon on, and tan theta is actually the ratio of sin theta and cos theta. Okay, so that's how the basic definition of these functions. But it turns out that these are actually very nice function, and the domain of these functions is the whole real number. So sine x is a function from the real number to close interval -1 to 1, because it oscillate between -1 and 1. So if you take the graph of sine x, this graph look like this. Right, it oscillate between -1 to +1, and you guys are familiar with all the values. So that is at pi by 2, you will get the highest value, which is 1, and you will get the lowest value when it is minus pi by 2, and so on. Right. So this is sine
Ma'am,
x. Yeah.
ma'am, can you just help me understand what this pi is here doing in the sine function? Like I know it's some angle, but can you just
Hmm.
help?
So
Pi
there
is
are
180.
actually there are actually several definition of pi. So sometime pi can be defined as the area of circle too. That one definition you can consider that pi is actually equal to 180 degree. Yes, that's correct. That 180 angle is also known to be a pi. So that is whatever this angle is known to be pi. There is one more description that pi is actually the area of a circle. So that is, if you consider the unit circle, that is the circle of radius 1, then we know that area of circle is pi r square. So pi also can be treated as the area of unit circle. So pi is actually an irrational number. So this 180 degree is also known to be pi. There are several reasons. So you can say that pi is actually a kind of irrational number, which is equal to, if you compute it in a degree format, it's equal to 180 degree. Or else, if you want it to be a quantitative thing, then it's actually the area inside this particular sum.
Why this
22.
much meaning for pi, ma'am?
Sorry, what?
Why this much of meaning? There are two or more, 3 to 4 definitions are there for pi. Why?
So initially pi was computed by area only, that what will be the area of this unit circle, that is known to be pi. But it turns out this pi appear in so many things, right? Now we know what is the value of 10 pi and all those things. So that's why it's
So
up to you.
all the
Huh.
values in between pi and pi by 2 and 0 are all expressed in pi, is it?
No,
Like,
not all, not all. Some of them, because
so
you
the
can treat
space which
pi
is
as
exactly
only
in
a
the
number.
middle of. Okay, so the value on the x-axis between 0 and pi by 2, does it become pi by 4?
No, not at all. So pi is
Oh,
a
how do you?
number. So
Ma'am,
pi is a
in this
number.
ma'am, in this degree, what will we use for pi, ma'am? We use pi as 180, or we use pi as pi r square?
No, you will use pi as 180 only. Pi is not equal to pi r square. Pi is, if you want it to be a quantity, right? A real quantity, how you will write it down, right? For example, root 2. You guys know what is root 2 is? Root 2 is the length of this particular hypotenuse for a right angle triangle with 1 unit edge. This is your root 2, right? So I want to say that pi is nothing but a number, right? So if it is a number, it should denote something. So quantitatively, it is this number, this much. Whatever area you can enclose by inside a unit circle, that number is known to be pi.
So what do you call the value on the x-axis between 0 and pi by 2?
Any real number. So pi by 2 is also a real number. So pi is actually a symbol taken for an irrational number. As you guys know, e, right? E is a number, and it cannot be written down in finitely many decimal places. Similar thing is happened for pi. Pi is also a number which cannot be written down in a finite decimal places. It's 3.14 something something something, and it goes on. So that's why we are adapting a symbol for this number, and that number is pi. So pi is actually a real number. So pi by 2 will become a real number.
So the number on the x-axis can be written in two forms. One is degree and another one is radian. Pi by 2 means you're writing it in radian. If you convert it into a number, then it is in degree.
180
That's
by
where you're getting
Okay.
confused. Someone has already put it up in the chat.
Yeah, it
Okay.
is indeed. Okay, fine. So let's move ahead. So these are the functions, sin x, cos x, tan x, you can understand.
Ma'am,
Now,
I had a doubt out like can we use the for sin x by x for Sandwich theorem? Can you explain that for cos and tan? Because I feel
uh,
like in one of the functions we say that we can't use sandwich theorem in that.
Yeah, we cannot use in 10 because 10 is defined for n goes to infinity. Because as n goes to infinity, 10 is also, because 10 is not bounded, obviously.
Okay.
If you consider 10x, it's a function from, we have, the domain is actually restricted. It's minus pi by 2 to pi by 2 to real number. And the graph of 10, you guys know, these two line will work as asymptote, minus pi by 2 and pi by 2. So for 10, we cannot say because it's not bounded. But for sine and cos, we can say they are,
Okay.
right? It's unbounded function. Okay, so now let's go to limit of functions. So limit of functions means here also we want to answer the question as, but here since function can be defined for every real number, we have limit. We can talk about limit as going to x is going to a finite value x naught. Okay, so what is limit of function means? So here also you want to just answer a question that as x goes to any number x naught, then where does the values f of x goes?
F
Okay,
of x naught.
no, not necessary. This is true for continuous function only. That's the definition of continuity. So as x goes to in x naught, f of x goes to f of x naught for all values of x naught, then or for that particular value of x naught, then you can say function is continuous. So but limit says that x goes to x naught, you have to think that what will be the number over which the function value is getting closer. It's not necessarily exact, it is getting closer and closer to. That's what we want to understand. So for that we have two type of notion, left hand limit and right hand limit. But before that, we can also think about this particular thing in terms of sequences. Okay, so I'll define a limit of function using sequence. Limit of function using sequences. Okay, so here, what does this mean? So we say limit x going to x naught, f of x is equals to some number L if for all sequences an such that an is converging to x naught, we are getting the sequence f of an. Now what is the sequence f of an means? You are applying the function f on each term of a sequence. First you are applying f on a1, then f of a2 and f of a3 and so on. In this way, whatever sequence you will get, that sequence is your f of an. So we say that limit x going to x naught f of x is equals to L if for all sequences an such that what are the sequence we are considering? We are considering those sequences which are converging to the number x naught. Right? We are considering those sequences which are converging to the number x naught. And for all those sequences, if you talk about the new sequence, what is that new sequence? That sequence is f of an. Then this sequence f of n should converges to the number n. Okay, so for all an such that an going to x naught, the sequence f of n should converge to L. So that is f of n should goes to L. So if this thing happen and this thing happen not for 1, 2, 3, it should happen for all. Okay, so if it is happening for all sequences which are converging to x naught, and for all sequences this new sequence f of n is going to a fixed number L, then that is called to be the limit of function. Okay, so I'll take one example for that. For example, we want to figure out what is the limit of limit x going to 0 of I'll take a simple number, so let's take it to be x cube. Okay, so this is what we want to figure out. Although it's kind of clear to you guys that the limit will be 0, but try to think about in this definition. Okay, so here, what are the different sequences are there which converges to 0? So the thing is, there are actually infinitely many sequences which are converging to 0. So we know that if you take a sequence, an is equals to 1 by n, this goes to 0. If you take a sequence an is equals to 1 by n square 2, this also goes to 0. If you take a sequence an is equals to 1 by 2n, this also goes to 0, and so on. So that means there are infinitely many sequences which are going to 0. But no matter what sequence you will take, we know that if an goes to 0, an into an into an will also go to 0 into 0 into 0. So we'll use that fact. Okay. So suppose an is any any arbitrary sequence, any sequence such that an is converging to 0. Okay, so assume that an is any type of sequence, any sequence. We don't know what is that sequence or what is the expression for that sequences, but we do know that this an is going to 0. Okay, so you know that an is going to 0 will imply an into an into an, that is the multiplication of 3 sequence, will go to 0 into 0 into 0. Right? This rule we know that if an goes to a, bn goes to b, multiplication of 2 sequence will go to multiplication of their limit. So that means what you figure it out from this thing is an cube will also go to 0. Right? So here what we get that if you take any sequence which is converging to 0, you can imply that the cube of that sequence also goes to 0. But what is that cube of this sequences? So if your an is a sequence, then what is the new sequence f of an? F of an is an cube, and this is going to 0. So that means here we can simply say that if an goes to 0, this implies an cube goes to 0, and this says that f of an actually goes to 0. So that is this 0 is the limit. So that means by the definition I can say limit x going to 0, x cube is actually equal to 0. Okay, so this is the meaning of limit of functions in terms of sequences. But here you have to take care of all sequences, not a 1, 2, 3 or any finite number. You have to take care of any random sequence which is converging to the point x. Okay, is that clear? Fine. This
Ma'am,
definition.
can you explain one more time?
Yeah. So here, see what we are doing. We say that the limit of this function is equals to L as x going to x naught. If you take any sequence which is going to x naught, for that sequence, if you consider the new sequence f of n, then that sequence should goes to L. Then whatever the number you will get, that is the limit of the function. So we can understand by this example. So here x is going to 0. So there are actually so many sequences, infinitely many sequences which converges to 0, right? So I'll take any random sequence. So suppose an is any sequence which is going to 0. But we know that as an goes to 0, an cube also goes to 0. So, but what is an cube? An cube is f of an only. Because if fn is given by the expression x cube, if f of x is x cube, then f of an will become an cube. Right? So that's why this means that f of an is going to 0. So this 0 is the limit of sequence. Okay. So this definition again, it's very tough to apply because here we have to take care of all sequences which are going to the number x naught. So instead of this definition, we will use the definition of left hand limit and right hand limit. Okay. So what does that?
Can you give a counter example in the same context?
Counter example means?
Give me a function which doesn't follow this. Like you showed
Okay.
that x cube, which is like following this theory, like, give us an example which doesn't agree with this.
So for that we can take, okay, so we can take an example. So suppose f of x is defined like this. So
Let's
it
say
is
minus
1.
1 the whole power n.
Minus 1 also you can take. Minus 1 to the power x. But minus 1 to the power x also you can.
Or a simple one like n square or something.
Can we take signum function?
One, that's what I was taking. 1 and minus 1 actually. See, there is an issue of taking minus 1 to the power x. So minus 1 to the power x will follow this definition because it's a nice function. It's an exponential function. And it's actually not defined for rational values. So I don't think we should consider that example. So let's stick with this one new example I want to take. F of x is 1 when x is greater than or equal to 0. And f of x is minus 1 when x is less than 0. Okay. So here if you try to find out, so here if an is a sequence which is going to 0, then you cannot talk about where does f of an actually goes. This is not defined. Right? Why it is not defined? So let me take one example of an. So suppose an is a sequence of minus 1 to the power n upon n. Okay, so suppose this is my an. So what is this an? So this an is simply, again, I'm starting with 1. So just forget about 0 for timing. So it's minus 1 and 1 by 2. And it's minus 1 by 3. And it's 1 by 4. And minus 1 by 5. And so on. So this is your an. Now for this sequence an, if you compute f of an, then what will be your answer? So what is the value of f of -1? What will be the value? Okay, so you guys can answer for these values. So what will be the value of f of -1?
-1.
-1, right? Because if x is
Less than.
less than 0, we are taking -1. And if x is greater than or equal to 0, we are taking 1. So this is
Okay.
-1. What is the value of f of 1/2?
1.
+1, right? Again, -1/3 is less than 0, so that's why -1. 1/4 is greater than 0, that's why +1. -1, +1, and so on. So here what we are getting? We are getting that an is going to 0, but f of an is not going to a fixed value.
Oh, okay.
Right? So in this case, you can say that limit actually does not exist. So for saying limit does not exist, it's okay if you just fix, if you find out one an which is going to your point x0, and for that an, f of an is not going to anywhere else. But again, this is not that easy case. It's easy for such a simple function, but if you have a complex function, it will take a lot of time.
Yeah, but this example made us understand the theory much better. Thank you for this.
Okay. Okay, fine.
Ma'am, will it go like this, -1 +1 -1 +1, or it is randomly to you?
No, it will go because I'm defining function f that way, in this way, right? For this particular f only, we are getting that.
Okay, ma'am.
This is your f of x.
Ma'am, here first we defined one fx. So this an, have you like calculated or you knew what the an is, or an is given actually?
No. Here we want to understand what happen if limit does not exist type of scenario. So here, if you want to say that limit x going to x0, f of x does not exist means there will be a sequence an for which an is going to x0, but f of an is not going to the value l, or it is not even has a limit. So that's example you want to take. So here what is happening, this function is does not have limit as x goes to 0. So for that, I just take any random an, not a random an, it's a well calculated an. So for this an is going to 0, but this f of an is not going anywhere. So this example shows, this choice of an shows that limit of this limit actually does not exist. So here, this shows that the limit x going to 0, f of x does not exist.
So the an does not have a limit, is it here?
No, f of an does not have a limit. An does have a limit. An is going to 0 only.
An is going to 0.
But the sequence f of an is not have a limit.
Okay. Why is it so?
See, f of an, if you compute, you are getting this thing, right? F of -1, f of 1/2. F of an means you have to apply function f on each and every term of sequence. If you apply f of -1, f of -1 is -1 itself. So -1 + 1, -1 + 1, right? We are not getting any fixed value as
But
n goes to infinity.
f of 1/2, what is it? It can't be
F
1,
of 1,
no?
no. So f of 1/2 is 1, na?
But what is the function we are applying? Is x to the power of 3?
No, this function, this new function, f of x is 1 when x is greater than 0, -1 when x is less than 0.
Okay. All right.
Yeah, I'm talking about this function, not x cube. Okay, x cube is a nice function, so everything will hold for that. Okay, so now let's go to the main topic, which is left hand limit and right hand limit of function. Okay, so again, if you are in a real line, if this is your real line, and if this is a point x is equals to x0, then we know that there are two directions by which we can approach this point x0. One from the left hand side, another one is from the right hand side. So this is the left hand side. Okay, don't get confused that we are going to right side, so this should be right hand side. No, we are approaching the point using the point x0 using the values which are over the left hand side of x0. That's why it's known to be left hand limit. Okay, don't get confused about the direction. I think you are not confused, I am making you confused, but fine. So this is known to be left hand side of the point x0, and you can approach the point from its left hand side, and you can approach the point from its right hand side. So in two-dimensional, we can talk about two types of limit. One is the left-hand limit and another one is the right-hand limit. And the question is, if you approach the point from left-hand limit, where does the value of function actually goes? And if you approach the point from right-hand limit, where does the value of function actually goes? And the thing is, if both values are same, then we can say that the limit exists and the limit is same as the left-hand limit and right-hand limit. So I'll explain that. So left-hand limit. So left-hand limit is denoted by this symbol, limit x going to x naught to the power minus. So whenever you see minus there, this means it's not a limit, it is the left-hand limit of function as x going to x naught, f of x. Okay, so this minus symbol is important. So if there is a minus symbol, it's not a general limit, it is limit as x going to x naught from its left-hand side. Okay, so this says that if you approach the point x is equals to x naught from the left side, from left, then where does the value of function f of x gets closer to, so that means where does it goes means where does the values f of x gets closer to, sorry, f of x get closer to which value? That's what we want to talk about. So I'll take example before that. So suppose I'll denote it by first graph. So suppose this is the function, it's just a straight line. Okay, I can make a little change in place of straight line. So suppose this is your function. Okay, and here is your point x is equals to minus 3. And what I want to ask is, and suppose this value is 5. Okay, so here kind of easy thing. If you approach the point x is equals to minus 3 from its left hand side, you just have to travel by the graph, right? And this graph value is getting more closer and closer to the value 5 as you approach the point x is equals to minus 3, right? It's easy if you see by the graph. As you approach minus 3, so suppose you are approaching minus 3, so for that you can take help of sequence. So suppose I'm taking one point here, suppose this is x is equals to minus 4. Okay, so this is the value f of minus 4, right? I'm going a little get closer, so suppose this is x is equals to minus 3.99999. This is the value f of minus 3, and so on. So that means as you are approaching the point x is equals to minus 3 from its left hand side, the values of functions are getting more closer and closer to the value 5. At this point is 5 comma minus 3. Right. So in this case, you can say that the left hand limit x going to x naught minus f of x is actually equal to, so here x naught minus has a fixed value which is minus 3. Minus 3 minus is actually 5. So this is the meaning of left hand limit. But here the thing is, we want to find that value where the value of function is getting closer and closer, not the exact value. Okay.
Matt, why is it 5 and minus 3?
Just the particular value. In place of ABC, I'm just taking a fixed values. Just an example.
Oh, it's not minus 3 and 5, huh? Oh.
Sorry, yeah, right. I always do that. Minus 3 and 5. Thank you. Yeah, so here the point is we want to figure out that value where the value of function is getting closer and closer, not the exact one. Okay, so for that, let me take one more example. So suppose you have a graph like this. Okay, so suppose this is the graph of function and this is the value 5. Again, I'm taking minus 3 only. So here, if you approach the point from its left hand side, what do you guys think where the value of function is getting closer and closer?
5.
Right, 5. So suppose this is something 4. So here, if you approach the point from left hand side, the values of function starting running over this particular graph, right? And as you reach the point x is equals to minus 3, it get very closer and closer to the point minus 3 comma 5. That is, the value of function is getting very closer and closer to the point to the value 5, right? So in this case, the left hand limit of the function will become 5 only. So you can simply say limit x going to minus 3 minus f of x is equal to 5. What about the right hand limit in this case? If you approach, same thing is true for right hand limit too.
4.
Right, because what is happening, if you approach the point from the right hand side, the graph, the function's value will follow this blue line, right? And it's getting very closer and closer to 4. It's not exactly 4, but as you approach the point x is equals to -3, if as you get very closer and closer to the point -3, the value of function will become 4 only. Since I'm taking here constant value, but you can take any number. Okay, so that means here the right hand limit are actually denoted by limit x going to -3 plus. In place of minus, we have plus here. F of x is equals to 4. Right? So this is the graphical meaning of left hand limit, right hand limit. Similar thing, you can talk about the sequences too, so that I'll just define. But important is understanding this. As you approach a point from left hand side, you have to follow that side of the graph, and if you approach the point from right hand side, you have to follow that side of the graph. And again, you don't have to worry about where does function exactly goes. We just want to talk about that point where it approaches. That means the value of function get more closer and closer to which value. Okay, as the limit approaches. You can think about these graphs as the road, and you are just traveling through that road, and you are just getting to your destination. What will be the closest location you will get? Okay, and thing is, if left hand limit and right hand limit both agrees, then we say that limit of function exists, and that value is same as the each limit, left hand limit, right hand. Okay.
Ma'am, it means we have to see only the approximate nearest value, not the exact
Right,
value.
not the exact value. For example, if I take, okay, so let's talk about one more example. So suppose this is the graph you have. Again, you guys, okay, so let me.
I have one doubt. Can the limit be, limit extends to some value be infinity? Like, in the case of asymptote,
It actually can be, because see,
can
e to
be.
the it can be, because you have concept of asymptote. So, for
Okay.
example, 10 only.
Okay.
In this graph only, you can see as x goes to pi by 2, 10x actually goes to infinity. So this can
Oh,
happen.
okay. So this is allowed. Okay. So you call this as limit, correct? So so pi
We
by
call
2
as
tan
that limit.
x is limit. Okay. Okay.
Okay. So yeah, so this is the example. So suppose we have a function represented by this graph. You guys are familiar with the concept of hollow point and a solid point. So the solid point means function value is there. So that is function value is there. And this hollow point means function value is not there. Okay, so for example, so suppose this is a line y is equals to minus x plus 3, assume. And this is the line y is equals to x plus 3, maybe. Or I'm not sure they will intersect at the same point or not. They will,
Yeah,
right?
let's hypothetically keep this as an example.
Let's
Yeah.
take assume.
Yeah.
So suppose these are any two values, and the value of function is here. So suppose this is x is equals to 4. This is the value 5. Okay. So here what is happening? This at 4, the value f of 4 is actually 5. That is the exact value at 4, x is equals to 4, value of function is 5. That is the meaning of this graph. If you find out solid point means function value is there. So that is this point is 4 comma f of 4. That is 4 comma 5. That is the value f of 4 is 5. But anywhere near the value 4, you have to follow the other graph. So that means if you want to find out the value of f of 4.00001, you have to take care of this line only. Okay, so on exact 4, you have the value 5. Around 4, that is very close to 4, you have to follow the graph. That's the meaning of this particular graph. Okay, so here, if you compute the left hand limit and right hand limit, so let's see what will happen. So what do you guys think? What is the value of limit extending to 4 minus f of x?
0.
0, right? Because ultimately, as you approach 4 from left hand side, this is approaching the point 0. Here, the value of y is 0 actually. Right? This is 0 comma 0. So the limit is 0. So what will be the right hand limit?
0.
0 only. Because again, if you approach the point from right hand side, limit is 0. So here what is happening? We are getting that left hand limit same as right hand limit. That means limit exists. So here left hand limit is same as right hand limit, which is equal to 0. So you can conclude that limit extending to 4 f of x is actually 0. And this is not equal to the value of function. right? So that's why when we talk about limit, we just want to understand where the function is getting more closer and closer to which value, not the exact value.
So what x equal
So
to
why
4
have you written
limit
f of 4 is equal to 5?
Sorry.
Sorry.
What?
Uh,
Yeah, right.
Can I go, Shugit?
yeah,
or-
please, please. Dilip.
Yeah, you've mentioned f of 4 is equal to 5, right? So,
Right.
how does that work? I mean, I'm sorry, I couldn't figure it out.
See, well, that's the definition of function, right? I am defining a function in this way, such a way that it follows the blue line when the value of x is less than 4. It follows this particular line when the value of x is greater than 4. And on 4, I am defining the function to be value equal to 5.
So hypothetical, it's a hypothetical graph, Dilip. That's what we started with.
Okay.
And
Okay.
that's right.
Samiksha, here at x equal to 4, limit exists, but it is not continuous, correct?
Right.
That's how- Okay, got
That's
it.
the meaning of continuity.
Okay,
So
got it.
the thing is, in limit, you just have to take care of a point where the function value get closer and closer, not the exact values.
Excuse
Okay,
me,
that's
ma'am.
the point. Yes, sir.
So if we have two functions which intersect at a point, so those two functions are continuous at that point of intersection.
It depends actually. Yeah, they can be continuous, but need not to be. Not the general thing. It depends on the expression of functions, which functions you are talking about.
Yeah, let's say like these two lines which are represented in blue, right?
Haha.
They intersect at that point. So let's say if that middle condition is not there, like if f
Then
of
it will be continuous.
okay.
Yeah. So what is the continuity means? It's simple that the limit should be equal to function value. Then the function is said to be continuous. Okay, so I'll state two remarks. And then we can. So the first remark is we say that limit x going to x naught f of x. This limit exists, and it's an if and only if condition. The left hand limit is same as the right hand limit, and then the value of limit is same as its left hand limit and the right hand limit. Same as the left hand limit, right hand. So this is the first remark. If left hand limit, right hand limit both exist and both are equal, then we can say that the limit exists and the value of that limit is same as the left hand limit and right hand limit. And the second definition is the definition of continuity. So we say a function is continuous if the limit x going to x naught f of x exists and it's equal to the value of function. Okay. So we say f is continuous at x is equals to x naught if the first condition is limit should exist. So that is limit extending to x naught f of x exists. And the second condition is that limit is equal to the value of f of x. So if this happens, then the function is said to be continuous that particular point. Okay, is that okay? Fine.
Yeah, perfect.
Now we
Ma'am,
have this. Yeah.
Ma'am, so in above example, if f of x was 0 instead of
Right.
5,
Then
then
it
we
will be
will call it
continuous.
a continuous. Okay.
Right. Now, by the graph, it's kind of easy to figure out that a function is continuous or not. If you have a gap type of thing, you can say that it is not continuous. It's known to be jump discontinuity, and the above one is known to be removable discontinuities. But in our course, we don't bother about the name. But by the graph, it's easy to say it is continuous or not. So, for example, if I ask you about this graph, now is this function is continuous at x is equals to 2?
No.
No, right?
This function is
Because
not continuous.
obviously, right, limit is not existing and left hand limit is not equal to right hand limit, so not continuous. Similarly, the above one graph too. This graph is also not continuous. Right? But if you draw a smooth graph, this type of graph, then this is continuous. So by the graph, it's kind of easy to figure out that a function is continuous or not. And by the left hand limit, right hand limit also, you can say that a function is continuous or not. Now let's go to the basic rules about limit and continuity too. So as like in sequences, we have similar type of rules here also. So again, if limit x going to x naught, f of x is equals to some number, let's take it to be capital A, and suppose limit x going to x naught, g of x is equals to capital B, then again here also the converse is not true. Converse is not true means if it can happen that the summation of two functions limit exists, but individual limit does not exist. So think of an example. So we know that limit extending to x naught, f of x plus g of x is equal to a plus b. Limit extending to x naught, f of x minus g of x is equals to a minus b. Limit extending to x naught, c times of f of x, c times the limit where c is any real number. And the last one says if g of x is not equal to 0 and b is not equal to 0, then the limit of division is same as dividing the limit. Yeah, fine. Okay, is that clear? Fine.
Yes.
Okay. Now from these rules, you can easily conclude that if so these same rules also state that if f and g are continuous, then you can say f plus g, f minus g, any constant multiplication of f, and f by g if it is well defined. Well defined means again g of x is not equal to 0 at that particular point. All these functions will be continuous. And it's easy to see. See, in continuity, in place of a, you will simply get f of x naught. In place of b, you will get g of x naught, right? So a plus b will become f of x naught plus g of x naught, which is the value of function at that point x naught. Similarly, here also you will get the same thing, right? C of f of x naught. And this is also same as f of x naught by g of x naught. So if f and g both are continuous at a point x naught, again I'm talking about a point only, is continuous at x is equals to x naught, then f plus g, f minus g, constant multiplication of f and division of two function will be continuous at the point x is equals to x naught. And in division, you have to take care that f by g should be a well-defined thing, and also the value of function should not equal to 0. So here, obviously, g of x naught is not equal to 0. If g of x naught is equals to 0, then we cannot say anything surely. Okay. Is that clear? Fine so far?
Yes.
Okay. Now let's talk about some of the basic continuous functions. So first fact is every polynomial is actually a continuous function, right? Every polynomial is a continuous function, no matter what x you will take, because polynomials are made of x. Yeah.
I don't think continuity is in week 6. We would like to check it because
Week 7, right?
week 7, sorry. It's not in week 7 is what I think.
Okay.
No,
Yeah.
it's there. Last topic.
Last topic is continuity, but also fine. If you know limit, the continuity is nothing, right? So we can stop here though. In the next lecture, we can continue from differentiability or continuity also. This is also the last fact I want to talk, that every polynomial is a continuous function, right? It's easy to see because what is polynomial? Polynomial is made of nice function. It's scalar multiple of x to the power n type of function, and x to the power n type of functions are continuous. So an x to the power n plus an minus 1 x to the power n minus 1 plus and so on, plus a1x plus a0, right? So here each of the factor is continuous, right? This is continuous because it's simply x to the power n function, and x to the power n functions are continuous because this also you can say that since x function is identity function is continuous, so x to the power n is continuous, and polynomials are just summation of continuous functions, so they are continuous. So each of them is continuous. So that's why p of x will become continuous. Okay. Now with this, we have one more small topic which is known to be the subsequences topic. So I haven't covered it, but we can talk about what is subsequence for a sequences. So far, any doubt? Anything which is not clear?
No, ma'am.
Okay.
Ma'am, I have just not understood one point. I've understood left limit, right limit, everything. But ma'am, how we have come from sequence, like how we are relating a sequence which we started with this function. That point, that link, I think I'm not getting. Relation
So
between function and sequence.
yeah, so what is happening? Sequence will actually help us to pick how we are traveling. So see, if I want to say that you have this is a straight line, and you have to go to the point x is equals to, let's take it to be 2, and you have to reach the point x is equals to 2. Okay, so what you will do, you will pick some points to get at the point 2, right? And you have two directions. You can come from left hand side, you can also come from right hand side. Now what does sequence do? Sequence actually help us to choose these points in a systematic manner. So you can choose first point, you can choose to be 1. Second point, you can choose to be, okay, 1 plus 1 by 2. Third point, you can choose to be 1 plus 1 by 3. I think I'm going in a wrong direction. So this should be, it goes to 1, right? Okay, you can approach it from right hand side. So this is your x is equals to 2. And plus, what I want to say. Okay, let's take it 0. 0 will be little easier. Okay, so suppose you want to go to the point 0, and for that point you have to consider some points to reach at 0, right? So what does sequence give us? Sequence give us a kind of stops by which you can reach 0. So one path is you can first reach to the point 1, then you can reach to the point 1 by 2, then you can reach to the point 1 by 3, then you can go to 1 by 4, and so on. But this is a one path, right? There could exist a lot of ways by which you can approach 0, right? So in place of these points, you can also consider some other points. So suppose I'll start with 2. You can also start with 2, then you can go to 1, and then from 1 you can go to 1 by 2, then you can go to 1 by 4, and so on. So these sequence will help us to figure out, no matter which path you will take, right? One path is this path, an is equals to 1 by n path. Another path is 1 by 2n path. Another path is an is equals to 1 by n square path. So these all sequences are telling us that, okay, by using these numbers also, you can reach 0, right? But what is the limit of function says that no matter which path you will take, you should reach at a particular fixed way. So for traveling f of x goes to L thing, you want to travel as x goes to x naught, right? So for this traveling, you can actually use the help of sequences. That's the involvement of sequences in the definition of limit that we want to talk about for all sequences. That where if for all sequence, no matter which path you will take to reach the point x is equals to x naught, or no matter what steps you will take to reach the point x is equals to x naught, for all steps, your function should go to a same value n. Then we will say limit exists. So we can say that sequences are giving us the stops or the ways to reach the point. And limit of sequence is also the same thing. By limit, you can figure out the destination. What you are doing. Is that okay? A
Okay, ma'am.
little bit understandable?
Yes, ma'am.
Samyuksha, we have not covered tangent and growth of functions.
Yeah, so I thought we can cover that in differentiability, but we can see. So here also in this week, I think we just touched the definition of tangent. So what are tangents? So tangents are those lines which actually demonstrate us where the function or in which direction the function is growing. So you can assume that tangent is a line which touch the point. If you are talking about tangent at point A, touch the point A comma f of A, and the slope of this line actually tell us slope of this line tell us the direction of growth of a function. of the function f of x. That line is known to be a tangent. So that means a line which is touching the graph a comma f of a, and the slope of that line is actually telling us where does the function will grow after this point. Okay, so that line is known to be a tangent, and we can actually have an equation of tangent. Since it's a line, we can have an equation of tangent, and that equation depend on differentiability of a function. So in differentiability, we can talk more about tangents too. Okay. Yeah, I was talking about subsequences. So what is subsequences? So subsequences too, because I think there are one or two questions in activity maybe related to subsequence. So subsequence is like picking up a sequence from given sequence. For example, if you have a sequence like this, 1, 2, 3, 4, 5, 6, 7, 8, and so on. Now from this sequence, I can pick one more sequence which is a part of this sequence only. But in subsequence, you have to take care of two things. One thing is, if you have taken a one term, suppose I have taken a 6 in my subsequence, then now the next term will be then you cannot go backward. So that means the next choice will be the terms upcoming to that term. So what I mean by that, so if you have a sequence like this, then one subsequence of this sequence will be 2, 4, 6, 8, 10, and so on. Right. So here what I'm doing, I'm choosing the uh, second term, fourth term, sixth term of the sequence. 6, 8. So this will be a subsequence. But in place of that, if you say, okay, I will take like this, that 1, then I'll take 5, then I'll take 3, then I'll take 7, and then take 9, and so on. Now this is not a subsequence, because here what is happening, you are choosing 1, then you are choosing 5, and then you are coming back. This is not allowed in subsequence. So when you want to construct a subsequence of a sequence, you have to go in only one direction. You cannot choose anything which is
Ma'am, I have a doubt
any
here.
previous term. Yeah.
Ma'am, you said we should not go back, right? If I
Right.
just choosing 1, 5, 6, 8 means I'm just choosing in a forward direction, but in the random manner means it's not
That's
forming
also a
in sequence,
subsequence.
right?
Yeah, that's also a
How
subsequence.
would be a sequence, ma'am? If just considering 2, 4, 6, 8, 10, it's a next even number. But 1, 5, 6, 8, there is a non-matching, ma'am.
Yeah,
It's not coming in order, right?
it's okay. It's okay. It's allowed in sequence, no matter in which fashion you will take. One thing I can say, okay, this is also subsequence. Can you please mute yourself? It's disturbing a little bit. Okay, so in place of this, it's okay if a subsequence does not follow a pattern. That's okay. It's not an issue for us. You can also take 1, and then you can take 1,000, then you can take 1 lakh, and then you can take 1 lakh and 1 rupee. Oh, sorry, 1 lakh and 1. This is also subsequence. It's okay if it's not following any pattern, because subsequence means it should be a part of sequence written in a nice format. There is a definition, mathematical definition, but it involves composition of function and all those things. That's why I'm just intuitively telling you what is a subsequence means. You just have to choose anything from your sequence, but the thing is you cannot come backward. You have to choose the next element should be the next element of the sequence one, next or any other. And it's okay if it does not follow a pattern. Okay, fine.
You mean to say
Nitish?
order is important here?
Order is important. So that means if you choose the fifth term,
Sequences is set?
subsequences, sorry, what?
No, generally isn't sequences a set or is a list?
No, sequence is a list. It's not a set.
Okay.
Yeah,
But
sequence is
I
not
don't
a set.
understand where order is like creating an issue. Let's suppose 1 by n and 1 by n square. 1 by n square is a subset of 1 by n. But what
So
if I change
uh,
order? Like,
see, order is important because when you define a sequence, okay, let me see. See, if your sequence is defined in terms of an, the subsequence will be defined in a subscript of something. Okay, so suppose this is some Rn. Now, what is the property of Rn is Rn is an increasing function. That's why this is the original definition of subsequence. Is an increasing function. Such a way that Rn is also a function over natural number, so it is an increasing function from set of natural number to set of natural number. So it's something like you have a sequence an, then you can construct any sequence with this way that a1 you can take you can take A6, you can take A8, but this increasing should be there.
Okay,
Then
okay.
only it
So you
makes
mean to
sense.
say, like, if I change the A8th term with A6th term, then that's where the issue. Okay, okay.
That's the definition of subsequence, choosing a
Okay,
subsequence.
got it. Thank you.
Okay. So, and the thing is, for a sequence, there is a very two nice subsequences. Those are the even term and odd term sequence. So, if you have a sequence AN, then you have two sequences. One is A to N sequence, and another one is A to N minus 1 sequence. Sorry, A to N minus 1 subsequence. So, what is this subsequences? The subsequences, we are taking all the even terms. So, we are starting with 0, that's why A0, A2, A4 term, A6 term, A8 term, and so on. And this is taking all odd terms, that is a first, third, fifth, seventh, and so on. What is the specialty about these two sequences? If these two subsequence goes to the same limit, then you can conclude that the limit of the sequence will be same. Okay, so this is the remark you can take. So remark says that if it's an if and only if condition, that limit of an is equals to L if and only if limit of the subsequence a to n is L, and limit of the subsequence a to n minus 1 is also equal to L. So that means if both subsequence converges to the same limit, then you can say that the limit of En is also L, and if the limit is L, then you can say that both subsequence will converge to the same limit. So this is the remark I want to give you. It might be helpful in some of the question, because I think there are some subsequence related question, one or two questions. Okay, is
Where
that
do you
clear?
get all this remark? This is not there in the syllabus, I mean, in the content which I was explained. Like,
Right.
I'm trying to understand from where I can get all these notes. Like, is it like ChatGPT, or should I explore more in the net?
See, yeah, because in the content, there are actually so many minor things are left. I mean, the definition is a little bit abstract. It's
Correct,
not
correct.
the
What have you taught? More than, like, there were more than half was skipped in the content. That's why I'm asking.
right, because we also know limit is it will take a little bit time to digest. So these are you cannot find it in one book, I'll say. Just something we solved some of, I mean, we saw practivity and practice assignment and activity question. So there questions are there. Based on that, I thought these remarks you should know. If you know these, then it will be easier to understand that question and also write it down, that question. So I have taken the remarks from activity only, that whatever questions you have to solve, so this much information you should know.
Got it, got it. Thank you.
Then you can actually think to initiate, right? Okay, sir, let me ask you one question. So I think it's there in activity maybe. So suppose an is sequence defined like this. So it is defined like 1 by n cube, and it is defined like n square plus 1 by n to the power 4 maybe. Okay, so suppose this is your sequence when n is odd and when n is even. In this sequence, how can you think about what will be the limit of n? Right? In such kind of sequence, you think that, okay, there is no starting point. How can we think, right? Here you should able to apply this concept, that okay, n is odd means this is a subsequence with odd terms. This is another subsequence with even term, and you have to figure it out. Okay, this is going to 0, this is also going to 0, so that means both subsequences are going to 0. So that's why the limit of sequence will become 0. So such kind of questions are there in which you may not get any starting point. So you have to recall these remarks, that okay, I can relate this question to which concept maybe. Then it will seems a little bit logical. Otherwise, in place of you guys also, if I first time just understand the definition of limit and sequence, I may not understand how to solve this question, right? I think so.
Yeah, very much true.
Yeah. So that's why I thought it better if you guys know such kind of remarks. Then you can at least you can think about something. Okay. It's okay. It's a long theory. So just practice some question. From practicing question, you learn some of the tips or things. So I would say just go and don't rely on theory in maths, right? Only your 30% is related to theory. not 30 actually, you can say 40% is up to theory. Once you understand theory, until and unless you practice a good amount of question, you won't be able to uh, actually really understand the theory. So you have to do practice, then only you will learn.
Yeah, that's what I experienced also. Like post week 4, it has all been like, even we know theory, when we go to the sums, it is like we need to
Yeah,
understand a lot of ways to solve the problem. That's what has
right,
become
right,
more important.
right. So that's why don't stick to theory. Once you have gone through the theory, that's all. You have to practice some of the good questions. And if you stuck to a question, that's actually important. If you solve all the question, that means you're not learning anything. So you should be stuck to a question. Just spend 20 to 15 minutes to solve that question by yourself. If not, then think other ways how you have solved the previous question, and those ways will work. Okay. Okay. So I think that's all. We can learn some of the things in the next class too, but uh, this is actually my last class. I won't take any other class after this. So that's say.
Kudos to you.
Can't
All the
understand.
sessions were awesome.
Sorry, what?
Like I can't understand what you said, ma'am. It's the last session now.
Yeah, this is my last session. So from now on, the other instructor will take classes. I won't take any class.
Why, ma'am?
That's all for me. I'm actually going.
Can't understand, ma'am.
Yeah,
Ma'am,
I'm
but
actually. Hello,
ma'am, I
I'm
would
audible?
like to say thank you to you because you have taken the previous classes and you have taught everything in so simple manner, and you were never
Yeah.
irritated by any stupid questions we were asking. So thanks a lot to you.
Yeah, I saw some sessions
Ma'am, yes, ma'am. That's
last.
a great achievement, ma'am. Not irritated.
Okay. Yeah, this
Yeah,
was my last session, so
your
I
sessions
won't
were
take
all
any other
awesome,
session.
Ma'am, are
and
you doing
yeah,
PhD in IIT Madras?
No, I'm going outside of India.
Oh, happy journey, ma'am.
Thank you. So all the best to you guys
Yes,
too.
would
yes,
it be
ma'am.
okay
Thank
for
you
you
so
to
much
share
and
your
have a
Thank you so
One
email
much,
by
ID?
one,
ma'am.
one by one, one by.
Would it be
Yes,
okay if you can
absolutely.
share your email ID, like for any doubts or anything?
Yeah, you can contact me. I don't think how much I will use this email anymore, but let's see. It's simple. samiksha@study.iitm.ac.in. That's all.
Ma'am, this much fast remains. It's difficult to read out, ma'am.
Sorry, what?
Ma'am, please can you send in chat, ma'am? It's very difficult to copy that what you
I
said.
have sent it. I have sent it in chat. I'll also upload these notes over the calendar. So as usual, you guys just go and download it from there.
Yes, ma'am.
Okay. Also, I'll just give you a tip that graph theory is so you will learn now calculus from week what is this 7 to 9, and after that you have 2 weeks of graph theory. So just complete your calculus before that, because in graph theory it will take a lot of time to understand you. It's a new topic. It's a new course. I mean, and they have covered so many things in that. So if you just I mean to say that just go fast from now on. You don't have to uh, you have to take a lot of time to understand graph theory, I would say,
Yes, ma'am.
because it's not that easy. I'm not scaring you. I'm just telling a fact that graph theory take time to digest.
Yes, ma'am.
So that's
Ma'am, which college you enroll into, right, for PhD?
I'm going to University of Delaware actually.
University of
Delaware, DLWR.
which country, ma'am?
It's in US.
USA.
So I hope I'll see some of you. That university is actually good for data science too. I've seen so many students are enrolled this year for data science, MS in data science. So might be some of you may want to do MS in data
Delaware
science.
University, yeah, ma'am.
Sorry, what?
Spelling of the university, ma'am.
Yeah, I'm writing in the chat.
If a chance to get admission there, let me come.
Yeah, you can try after your bachelor's. You can try.
Are you going for PhD?
PhD.
Okay. Congratulations.
Okay, thank you guys. Chalo.
Ma'am, are
Bye
you
bye,
not
all the best.
NRI, ma'am?
Sorry, what?
Are you NRI?
No. I'm not NRI yet.
No, just asking my way saying I'm just going for PhD for foreign countries, ma'am. That's why I asked.
Oh, okay. I'm just
Samiksha,
going.
your
I'll come back.
sessions were all wonderful, fabulous, and just want to extend my huge thanks. There are a lot of
Yeah,
things which you
thank you,
cleared over your
thank you.
sessions, which was not which I had difficulty to understand over the context. So thank you so much, and have a good year ahead.
Thank you.
Ma'am, do they provide all your of your expenses like fellowship and everything?
Right. Yeah, they are giving me a stipend and all. That's why I'm going. Otherwise, it's not possible, right?
Okay, ma'am.
Okay. So all the best, guys.
Thank you,
So
ma'am. All the best to you too, ma'am.
attend all the session. Be patient and try to handle this Maths 1 course. I mean, this Maths 1, they have so many concepts, so many good concepts in a very small duration of time. So it's something I would say. I think you guys also agree with that. It only limit in 1 week, it's not a good thing. Also limit with sequence with 1 week. They should have extended at least for 2 to 3 weeks. Calculus part only. Without wasting so much time on that quadratic functions, right? All those functions can be wind up in 1 week. But these calculus part need some time. But it's okay, you guys can go through it. So okay,
Yes, ma'am.
chalo, bye.
Bye, ma'am.
Thank you, ma'am.
Good night.
Bye, ma'am. Good night, ma'am.
Bye, ma'am. Bye, ma'am.
Bye, ma'am.